Hello everybody, today we're gonna discuss about analysis of the partially balanced lattice design in our software. And this partially balanced lattice design is similar with balanced lattice design, in which balanced lattice design has some features. The first one is the number of treatments must be a perfect square. That means 49, 81, 36, 25, 164. And the second criteria or the second feature of the balanced lattice design is that the block size is equal to the square root of the square root of the number of treatment. For example, if you have 25 treatment or 49 treatment, so by default your block size will be 5 and 7 respectively. And thirdly, the number of replication is one more than the block size. For example, if you take 25 treatment and you have 5 block size, so by default your number of replication will be 5 plus 1 because the block size is the square root of 25, so that the number of replication is 1 plus to the block size. So for 25 treatment, you'll have 5 block size and 6 replication. So these are some feature of balanced lattice design. But coming to the partially balanced lattice design, in all things are similar. That means the treatment is perfect square. The block size is equal to the square root of the number of treatment. But the difference between the two, that means the balanced lattice design as well as a partially balanced lattice design, is that the number of replication, because the number of replication is not prescribed as a function of the number of treatment. So you can give any number of replication. So if you give, for example, two replication, by default this design will be simple lattice design. And if you assign or if you give the number of replication to 3, it will be a triple lattice design. If you give for replication, it will be quadruple lattice design, and so on. So when we have a different choice, that means when we have flexible option to choose the number of replication, it will lead to some negative effect or disadvantage. One of the disadvantages of having flexibility in the choice of replication is we we may lose the symmetry in the arrangement uh, of the treatment over block. So every pair of treatments at auger together once we lost the symmetry. And the second one is the comparison of the treatment within the same block is have higher precision, and vice versa. That means comparison of the treatments not in the same block have a low precision. So due to these two different level of precisions, data analysis is somehow is complicated. So in order to run this partially balanced lattice design, you have to incorporate the two packages. That means agricultural package as well as a mass package, and you will let assign replication here. You have to submit these two packages into our studio. Then I used here is two replication, and each is equals to 25, means each 25 treatment will be found in both replication 1 and replication 2, so that let's assign replication 2. So by default this design will be what it is. It will be a simple lattice design because we used two replication, and the block size which is equals to the block sizes for each replications we have 10 blocks, and for each blocks we have 5 uh, repetitions, so that the block is you have to assign in this way. So type this and submit to our studio. And if you want to see further the blocks, yeah, the block will be split into different forms. So these are the block structure, and again the treatment. So we have 25 treatment. You have to assign those 25 treatment in this fashion, starting from one end with 25 treatment. Then yield maybe is in ton per hectare or kilogram per hectare, whatever it is. Consider this as an example. So type this and submit to our studio. This is the response variable. The response variable. So in order to get the function of simple lattice design or the partially balanced lattice design in our software, you have to type this one in order to get the function. Use the function start structure, then piv.test. So this will give us detailed information about the partially balanced lattice design. Here is the block, here is the treatment, here is the replication. The Y is indicates for the response variable, maybe it's planted, grain yield, whatever it is. And here is K, the block size, and here is the method. It will give you three different methods. The first one is the restriction, maximum likelihood, and it's very good and it's recommended. Then by default R will consider the restriction maximum likelihood, and again here also maximum likelihood, and here also the variance component model. And the test, that means if you want to separate the mean separation among the treatments, so you can use either the least significance difference or the TK. And you can assign also alpha. Here is the level of significance into 0.05 or into 0.01, depend on your preference. And console is equals to false, or it is a logical, it's a print out the result to the console. And the group is a grouping of the treatments like A, B, C, D, and such like things. So these are just the function for the partially balanced lattice design in our software. So the default method is let iterate. You can give any name that you want in this section. So WAC, I assigned this WAC, and the function that are going to analyze the partially balanced lattice design is pviv.test, and you have to indicate the block, you have to indicate the treatment and replication. Then here also the response variable that you are going to measure, or in our case it's yield, and K is the block size, which equals to 5, because the square root of treatment, our treatment is 25, so square root of 25 means which equals to 5. So the default method will consider the methods as what? As the restriction maximum likelihood. So the default is the restriction maximum likelihood, and if you want to change into other method, you can use in this way. So let's use this first. Yeah, and so you can get a number of detailed information about things. I will come later, but if you want the method, all things are similar with this one. But if you want to convert into the VC, that means the variance component model, and if you want to test the instead of LCD, or if you want to change it to TAKE, so just simply write here in the quotation TAKE, and also here in the variance component, the method. But as I mentioned before, the default method is here. That means considering the test is least significance difference, and again also the method of estimation is the restriction maximum likelihood. So in this way you can analyze the partially balanced lattice design in our software. So let's assume that you choose the first one, uh, this one. So the work model means piv.test, the block, the treatment replication, the yield, and k is equals to 5. Then the method is the restriction and maximum likelihood, and the test is the least significance difference because it's default method. So let's see the ANOVA if we choose the method, the restriction and maximum likelihood. So if you use the print function, it will display all the entire information in this in our software. But let's see one by one. So if you type work and attach ANOVA, so you will get the analysis of variance in this way. Yeah, analysis of variance in this way. And again, if you type is the model, so it will tell you which model you are used. So the default it is obvious. So the default is restriction maximum likelihood. Yeah. So it will show you which type of models that are you used. Yeah, it is obvious by what? By the restriction maximum likelihood. And again, if you want to check the f statistics, that means it will give you either a key-in information criterion and also the a key-in and the Bayesian information criteria if you attach the f stat. So f stat indicates to help us with the model comparison. So type this, it will give you the f statistics, and the means it will give the entire summary. That means the standard deviation, the standard error, the first quantile, third quantile, and 50%, and anything. It will give you the entire summary of the study variable. That means the grain yield. So if you type this, you will get this information. Yeah, here is the yield, adjusted yield, standard error, standard deviation, minimum and a maximum value in their quartile. So by this way, you can get the summary or the statistical summary of the grain yield. And again, also the method also it is obvious. And here is the parameters that they are going to use is like the test is LCD. The name of the treatment is TRT. The treatments are 25. The block size which equals to 5. Blocks which equals to 5. And the replication is 2. The level of significance that means alpha which equals to 0.05. So in this way it will give you detailed information. So groups simply give you A, B, C, D. Yeah, just like that. So you can get here the groups in this way. So the highest yield was obtained from variety 11, which is 23.55 ton, which is statistically par with all her treatment 14, 15, 1, 22, 24, and up to treatment 3 are statistically par, but its highest yield is obtained from the variety of treatment 11. And again, you can also get the bar2. Bar2 means it is the variance covariance matrix. The variance covariance matrix is a square matrix that contains the variance and covariance associated with several variables, and often used to calculate the standard error of the estimator function of the estimator. So if you want that, type this, you'll get uh, this detailed information. Yeah, so the variance covariance matrix. So I just let create here is WAC2, other method WAC2. So let's create here, then let's use the function. All things are similar. Let's change the method into from the default, that means from the restriction maximum likelihood to the VC. And also you can also change this into take. Then uh, let's submit this to, let assign as WAC2. Yeah, so run this, so you will get uh, this information. Yeah, yeah. So when you change the variance component model, you get the replication degree of freedom and the treatment unadjusted, the block within replication, and the residual. How to calculate the replication? As you know that we have two replications, so degree of freedom for replication is 2 minus 1. And again, the treatment unadjusted here is we have 25 treatment, so 25 minus 1, it will be what, 24. And here is the block. In order to calculate the block which equals to r into k minus 1, so our replication is 2, then put it in bracket. Our k is square root of 25, that means 5, so 5 minus 1, which equals to 4. 4 times 2 is 8. And again, how to calculate the residual? The residual is somehow it is a complex. Let's do that. So the residual is, you can find in this one. So k minus 1, yes, k minus 1, and times, again, put it in bracket, then rk minus k minus 1. So k minus 1, which is equals to 5 minus 1, yes, it is obvious, 4, then times rk, our number of replication is 2, 2 times 5, which equals to 10, then let's put this in bracket, yeah, let's put in the bracket. So rk, which the value of rk means, we have r is 2, k is 5, so which is equals to 10, then minus the value of k is square root of 25, which is 5, and again 5 minus 1, so put this one, so 10 minus 6, which equals to 4, yeah, then this value, which equals to what, to 4, then out of the bracket we have k minus 1, so 4 times 4, which equals to 60. So by this way we can calculate, we can calculate the residual. So if you are interested more, please comment in YouTube description box or through my email. So this is all about today's lesson about the partially balanced lattice design in our software. If you want to convert this one into triple, so you don't need to bother yourself with anything, so just simply 3. If you want to change into quadruple, 4. So it is very easy. And if you have any question regarding to my tutorial, as usual, address me through YouTube description or YouTube comment box, or alternatively you can use my email. Thank you for watching. Have a nice time.